Dear students, welcome back to my channel Physics World. Today I have come with the third part of physical quantities and measurement. In the previous presentation, I had given you a question. This question was given to you in the previous presentation. A given quantity of a liquid is heated. Which of the following quantities will vary and how? Explain your answer. That means these are the three physical quantities. So here is your answer. When a liquid is heated, mass does not vary. Why it does not vary? Because we know that mass is the amount of matter contained in a substance or in a body. Therefore, it does not vary. So mass remains constant. Next, we are coming to the volume. We understand that anything when heated, it expands and contracts when it is cooled. In general, of course. There is an exception, that is water, which shows the anomalous behavior. Therefore, volume will increase in general for the liquid. Exception is water when heated between 0 degrees Celsius to 4 degrees Celsius. Instead of increasing, it will decrease. So the word which you are supposed to use is increase. You have to be very precise with your answer. You cannot say it will vary, because they have also asked you which will vary and how. So you have to say that this is going to vary and it is going to increase. Similarly, when we are discussing about the density, we shall discuss it on the basis of a formula which we have learnt. We know that density is equal to mass upon volume. Mass remaining constant, density is inversely proportional to volume. Thus, if volume increases, density decreases. So, density will decrease. However, the exception is water when heated between 0 degrees Celsius to 4 degrees Celsius. At that time, the density increases. Density increases. Now, dear students, the next thing which we will be discussing is relative density. So, let us see, when we are talking about relative density, it is actually two words put together. One is relative, the other is density. The meaning of relative is that there is a comparison between two things. Over here, of course, when it is coming prior to density, it means that we are comparing the densities. And when we are comparing two things, of course, we will take one of the things as a standard quantity. That means we will have to take some density as a standard density, and on the basis of that standard density, we shall be comparing the densities of other substances. So, the relative density is therefore the comparison of one density with another standard density. The standard density is taken as that of water at 4 degrees Celsius. Why it is taken as a standard density? Well, at 4 degrees Celsius, the water's density is 1 gram per centimeter cube. That means it occupies a centimeter cube, 1 centimeter cube of volume or space when the mass is 1 gram. Also, water is easily available everywhere. So, standard density is taken as water as that of at 4 degrees Celsius. So, we define relative density as relative density is the density of the substance upon the density of water at 4 degrees Celsius. This is very important, because we know that the water between 0 degrees Celsius to 4 degrees Celsius shows anomalous behavior. So, we have to precisely mention the temperature at which we are taking the standard value, and this has to be mentioned every time, whether we are doing the numerical or we are writing theoretical answers, wherever we have to write down the formula. So, everywhere this mentioning of at 4 degrees Celsius is very, very important. Next, we are coming to the next part. Over here there is one example given. Density of mercury is 13.6 gram per centimeter cube. Then what will be the relative density of mercury? Now, relative density of mercury will nothing but relative density of mercury upon density of water at 4 degrees Celsius. So, we can write 13.6 gram per centimeter cube divided by 1 gram per centimeter cube. So, the same units, because the units are in the same system and therefore, they are getting the same units, the same physical quantity. So, they get cancelled out and we get relative density of mercury is 13.6. No unit, this has to be noted down, there is no unit of relative density. We can also calculate the relative density through comparison of masses. If the volume of the substance and water are kept same, that means, if the volume of the substance we are going to take, if it has been taken as V centimeter cube and the volume of water is also taken as V centimeter cube or any value, it can be 1 centimeter cube, 2 centimeter cube, whatever, that has to be kept same or equal, then the relative density can be calculated by comparing the masses of the substance and water at 4 degrees Celsius. Now, dear students, we will see how we can write the relative density of a substance by comparison of the masses. So, we can write relative density is density of the substance upon density of water at 4 degrees Celsius. What is most important, dear students? 4 degrees Celsius. Now, that can be written as mass of V centimeter cube of the substance upon mass of V centimeter cube of water at 4 degrees Celsius. Again, this 4 dear students, this 4 degrees Celsius is very important. So, V centimeter cube means the volume can be anything, 1 centimeter cube, 2 centimeter cube, but in both the cases it will be the same volume or equal volume. So, mass of any volume of the substance upon mass of the equal volume of water at 4 degrees Celsius. Here precisely, dear students, we are going to use the term equal volume of water, because equal means one is equal to the another. So, equal has got a specific meaning and therefore, we are going to use this term, and dear students, we will write 4 degrees Celsius. Many books do not mention 4 degrees Celsius over here. Assuming that by now you have understood that, and you, however, in physics if you do not mention this, you definitely lose marks. So, please do not forget to mention 4 degrees Celsius. Now, let us see what is the relative density of mercury. Now, relative density of mercury is 13.6 shown previously. We had already calculated it is 13.6 and it has no unit. However, what it means when we are comparing the masses? It means that the mass of a certain volume of mercury is 13.6 times the mass of an equal volume of water at 4 degrees Celsius, right. So, mass of a certain volume of mercury is 13.6 times the mass of an equal volume of water at 4 degrees Celsius. Here, children, you must see that this I have done on purpose. I have written same, underlined it, and I have written over here an equal volume. Equal and same are different. Same means it can be almost same also, but equal has a precise meaning. But children, over here I would prefer you write the second definition of relative density. If they ask you to explain that relative density of mercury is 13.6, So, what do you understand by this statement or explain the statement? So, I would prefer that you explain it through density. Let me tell you how. The density of mercury is 13.6 times the density of water at 4 degrees Celsius. So, over here you do not have to remember that we have to say that for a certain volume of substance and for an equal volume of water, all these things you do not have to remember. You have to simply say that they are the comparison of densities. However, if you simply say the mass of a certain volume of mercury is 13.6 times the mass of water at 4 degrees Celsius, then you go wrong, because you have to mention an equal volume of water. So, remember children, if you have an option, go by the second difference or to understand or to write the difference. Now, relative density is a pure ratio and has no unit. Okay. This we have seen earlier that the same units get cancelled out. When you compare the densities, the unit cancel out, and also when we compare the masses, the units cancel out. Now, we will see, dear students, how do we determine the relative density of a liquid using the density bottle. Step 1, find M1, that is the mass of the clean dry density bottle. First, we take the clean and dry density bottle and find out its mass with the help of a physical balance. This we already have studies how to take the mass. So, I am not going into a detailed explanation of that. So, using a physical balance, or we can also use an electronic balance, find the mass M1 of the clean dry density bottle. Next, step 2. We find out mass M2. What we do is, we take the density bottle, fill it up entirely with water, put the stopper. As the water runs out of the hole, we clean it dry, wipe it dry, and then we take its mass. Now, we have to remember that the water is at 4 degrees Celsius. So, that gives us the value of M2. Step 3. We take out the water from the density bottle and we make it dry, clean and dry, and then we take the liquid inside the density bottle, completely fill it with the liquid, put the stopper. As the liquid runs out through the hole, some excess liquid, we wipe the density bottle clean, and then we take the mass M3, which is the mass of the bottle filled with the liquid. So, we have step 4, that is M3 minus M1, we find it out, that is the mass of only the substance or the liquid, over here liquid, and M2 minus M1 is the mass of water at 4 degrees Celsius. Both of them have equal volumes. Now, dear students, this is how we are going to find out the relative density of the liquid. Mass of any volume of the substance, mass of an equal volume of water at 4 degrees Celsius. So, we can write M3 minus M1 in grams divided by M2 minus M1 in grams. Grams gets cancelled out and we get M3 minus M1 divided by M2 minus M1. Again, one thing to be noted, dear children, that it has got no unit. So, relative density, once again a small recapitulation, relative density is a comparison of similar physical substances and or physical quantities, and therefore, their units cancel out, and therefore, it is a pure ratio, pure number, it does not have any unit. Now, children, we are coming to the numericals. This is the first numerical from the concise physics. So, let us see, the density of air is 1.28 gram per liter. We have to express it in gram per centimeter cube as well as kilogram per meter cube. How do we do this? The density of air is 1.28 grams per liter. Now, we know that 1 liter is 1000 milliliter. So, 1.28 gram divided by 1 liter, that is equal to 1.28 grams divided by 1000 milliliter, right. That means, now 1 over here, another thing we do understand that 1 milliliter is equal to 1 centimeter cube. So, we can write that is equal to 1.28 gram divided by 1000 centimeter cube. Now, when we are doing this calculation, I will just show this calculation over here. 1.28 divided by 123,000. So, now if you want to do this calculation, you can directly do it. Write 128 over here, and remember your decimal was over here. So, it goes 1 place, 2 place, and then comes over here. So, over here there will be a 0, there will be a 0 over here, and the decimal over here, and of course, before the decimal also there will be a 0. So, we get the answer as 0.00128 gram per centimeter cube. This is your answer to the part 1 of the question, where you had to find out in gram per centimeter cube. Now, dear students, you have two options. Many children, they ask me that, ma'am, do we have to write the answer statement? My answer to you is this: while you are doing the numericals, you anyhow are using a lot of mathematical terms. So, you need to use your mathematics, your concepts of physics. So, try to minimize your English in this, because you are tested for your physics over here. So, if you are boxing your answer like this and writing answer to which part, then you do not have to write down the answer statement separately for this. In physics, not in mathematics or any other subject, but for physics, if you write it over here, answer part 1, I think that would be sufficient, because the idea of writing the answer statement is to highlight your answer. Over here, you are boxing your answer and highlighting your answer. Next part is to find it out the density in kilogram per meter cube. So, dear students, we know that 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. So, we will write this value, multiply it with 1000 and write the unit over here. So, that brings us back to 1.28 kilogram per meter cube. This is your answer number 2, which has been highlighted by boxing it and written answer number 2. Now, dear students, this is the second question. The dimensions of a hall are given to you. The density of the air is given in kilogram per meter cube. You have to find the mass of the air in the hall. So, we know that first of all, whenever we are writing any answer to any numerical, what we are supposed to do is, we are first writing the given. So, given the dimension of the hall we have mentioned, therefore, volume V of the hall, multiply all these 3 and we get the answer in meter cube. Meter into meter into meter is meter cube, 10 into 7 into 5 is 350. Density D of the air is given as 1.11 kilogram per meter cube. While noting down this given from your question, children sometimes go wrong in the first step. Dear students, this is your first step of noting down the values. After writing the values, please cross check, because once you have done the entire question with the numerical, with the formula, calculation and all, and then if you find out that if you have gone wrong at the first step of copying down the values, that is very, very disheartening. So, please, after writing the values, just do cross check whether you have written the same values or not. Now, what we have to find out is mass m. So, what we have done is, we would represent volume as V, density as D and mass as m. We have clearly written it over here. So, we do not have to write where volume, where V means volume, capital V. So, all those things we do not have to write separately. We are minimizing our work of defining things. We have already defined over here. D is equal to m by V, therefore, m is equal to D into V, m is equal to 1.11 into 350. So, we get this value and we can again box our answer and write answer. So, that is the mass of the hall. Next is question number 3, dear students, which I give it to you as homework. So, I guess you will be able to do this question yourself. If you have any doubt in this question, you can comment. I will come with this next presentation including this question. Otherwise, I move on to question number 4. The density of alcohol is 600 kilogram per meter cube. Express it in gram per centimeter cube. The solution, first we will write given once again. Density of the alcohol is 600 kilogram per meter cube. Okay. Now, children, you have to express it in grams per centimeter cube. So, 1 gram per centimeter cube is 1000 kilogram per meter cube, or 1 kilogram per meter cube is 1 by 1000 gram per centimeter cube, right. So, therefore, 600 unitary method, 600 kilogram per meter cube is equal to 1 by 1000 into 600 gram per centimeter cube, that is 6 by 10, that is equal to 0.6 gram per centimeter cube. Now, dear students, again I have left question number 5 as homework. Now, dear students, this is your 6th question. Let us now try to solve this. The 6th question. A piece of wood of mass 150 gram has a volume of 200 centimeter cube. Find the density of the wood in CGS unit and second in the SI unit. So, first of all, we will write the values that are given to us. So, given mass m is given to us, that is 150 grams, volume V is given to us, that is 200 centimeter cube, density D has to be found out. So, we have written m, mass will be represented by m, volume will be represented by V, density will be represented by D. So, we have written everything. So, now we have to find out the density first in the SI unit and then in the CGS unit, and secondly in the SI unit also. So, since both the values are given in the CGS unit, it suits us. So, the first value is very easy to be found out. E is equal to m by V, m is given, V is given, we substitute the values and we directly get the value of D, the density, in gram per centimeter cube. Box the answer and write answer to part 1. Okay. Next, we write 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. Therefore, 0.75 into 1000, that will be your answer in kilogram per meter cube. So, you multiply now. Now, since it is multiplied not divided, therefore, the decimal shifts to the right. So, 1, 2 and another, so 750 kilogram per meter cube. So, that is your answer to the second part. Now, we will come to question number 7, dear students. Calculate the volume of the wood of mass 6000 kg if the density of the wood is 0.8 gram per centimeter cube. Now, it is given that mass m is equal to 6000 kg, okay, and the density capital D is given as 0.8 gram per centimeter cube. Now, children, we can see that this is in the SI unit and this is in the CGS unit, right. So, whenever there is a difference in the unit, we have to always change everything in the same system of unit. And I am sure by now you are in class 8, so you know that. However, remember that change you must make then and there. That means when you are writing the value of given. So, after writing 0.8 gram per centimeter cube, write immediately what will be its value in the SI unit. So, you write that since 1 gram per centimeter cube is 1000 kilogram per meter cube. So, multiply this with 1000 and write it immediately and underline. That is so important. Why? When you are substituting the values, you do not have to search which value you have to substitute. So, D is equal to m by V, mass, one value is only written over here, you substitute that. Density, you have underlined the value which you are going to substitute. So, substitute that. Now, find out the value and you get the answer in meter cube, which is the SI unit. That will be all for today, dear students. If you have liked this presentation, do not forget to like, comment, share and subscribe. Dear students, please comment. Your comments mean a lot to me, and if you have not subscribed yet, please subscribe to my channel for more such presentations. Thank you.